Hello everyone, welcome to MATLAB programming course. Today we're going to start a new chapter which is really important, and I would like to say that from today on we're really into programming, and the concepts that we will learn from today you will frequently see in every MATLAB program around you. It is vital that we completely understand these parts and the functionality. We're going to cover a lot of examples on these stuff. The chapters that we already learned are going to serve us very well during these two coming chapters on vectors and matrices. I would like to start by letting you know that MATLAB name also came from Matrix Laboratory, which indicates how fundamental the matrices and vectors are to MATLAB programming, and it constitutes a great part of MATLAB syntax. So let's get started. Vectors are the first identity that we're going to cover today, and they're really important because once we learn how to deal with vectors, it's going to be very easy to extend what you learned and implement it on matrices as well. Therefore, you are basically learning matrices and vectors at the same time. So what is a vector? As we learned before, we can define a number and put it to A, like A this one, or B equals to -3. But there are occasions that you would like to associate two or more numbers to a single variable. For example, I would like to say C equals for example, I'm calculating the speed of a car as an example. So what is important in our physics problem is that we need to know the distance, we need to know the time, we need to know a speed, acceleration, speed of wind, and stuff like that. You know, there are a lot of factors and parameters that are associated with our problem. And let's imagine it this way. Let me clear up the screen. We have three cars that are going to compete with each other. So the first car, I call it A. And what are the important things? I wanted to compare the first car speed to the second car speed to the third car speed. And the same with acceleration of the first car to the second car and to the third one. It will be very hard if I wanted to introduce different variables for a speed of the first car, then velocity of the first car, then the acceleration of the first car. You know, it's going to be very hard to maintain the consistency of the program and just to remember what variable was that. Therefore, the vectors come into play. The way that we're going to define the vectors is using brackets. So if I say A, open bracket, and then I put 1, then space, 2, space, 3, any number, okay? So you can extend it to as long as you want. But let's keep things simple, so when we understand it completely, we can work on the other parts as well. I close the bracket, and if I hit enter, you will see that now A contains 3 numbers and not a single one. And this is something new that we learned today. Imagine that the first one is the distance, the second one is the velocity, and the third one is the acceleration of the first car. Now, if I say B equals 1, 4, and 7, close parentheses. Oh, sorry, I forgot to put equal sign. So if I do that, now B is like that, and I can introduce C as 3 and 1. I just put numbers in it that doesn't make sense in some cases, but it's not important. The point here is I can now associate 9 different values, 9 identities to 3 vectors and just do the calculations. And now it's much easier to understand that we're talking about the speed of the car C. So we definitely go to this item. Now we're going to talk about the distance in car A. So we go to this item. And this is the core concept behind the use of vectors. And let me clear up the screen. Another important point while using vectors, these are all the basics, by the way, and we get hang of it as we solve some problems on it. The other important thing that I would like to say that, for example, if I define a new variable, which is in kind of vectors, you're not limited to 3 items, because we conveniently define 3 as to be associated with X, Y, Z, but literally you can go, as you like. There is no limit for you. One way to do vectors is like doing this, right? The same result. I would like to say that you can also put comma between, comma 2, comma 3, comma 4. And you would see that the same result appears. I did that example because there are some textbooks that prefer to put with comma and the other ones not with the comma, just with the space. And so you can do that as well. It is, however, different when we put A equals 1 semicolon 2 semicolon 3. I did that thing the same as above, but now let me add one more to make it like the one above. But here, as you see, I use semicolon instead of comma. So if I do that and hit enter, you will notice that now my vector is vertical. It's not horizontal. And it's really a fundamental concept in vectors and matrices. And we should learn that very, very well, because once we come to matrices and they're going to be algebraic calculations, they're going to be multiplications of the matrices, and it's just a very, very crucial point. Now there are other important parts that I want to emphasize here. So let me clear up the screen. And we have defined variable b, which has 3 parts. Now imagine that it's a vector. You wanted to convert this horizontal vector into a vertical vector. So instead of just retyping it into with the semicolon, what you can do is put b and single quotation mark. And if you do that, hit enter, it automatically changes the horizontal part into a vertical part. And if I repeat the same thing again, answer, it's gonna bring back the same result. Now we have B again. And it's very, very important. Another point which is worth mentioning is, do you remember the car, not this one, let's define it again. 1, 2, 3, 4. Okay. As you remember, and this was the example of the car that we just explored, and this was like the velocity. Of course, it was 3 items. It doesn't matter. So 1, 2, 3, 4. It's a new vector. It represents some variables. So this might be distance, velocity, acceleration, and the speed of the wind, for example. And now someone tells you, okay, now I am specifically interested in the velocity of the car A. Could you give me that? One way is, so you look at it and say, okay, it was a second item, so 1, 2, it is 2. But what if I wanted to extract it and do some calculation on it? I do have like 10 cars and I want to compare only the speed of these cars together. So what we can do is to extract each car's speed and then compare them together, or do some statistical analysis on them. The way that we can extract an item out of a vector is to type the name of the vector and open parentheses, 2 close parentheses. So what it's gonna do is going to extract the second item of this vector, which here it happens to be 2. So let me make a better example just to make it clear, like 3, -1, 7, 9, 10, 4, -12. So I do have 1, 2, 3, 4, 5, 6, and 7. I do have 7 items in my vector, which is like that. And then someone tells you, I'm interested in your 4th item. So I would say B4. What it does, it extracts the 4th item out of my vector, 1, 2, 3, and 4. How about then the 6th item? So it's gonna be 1, 2, 3, 4, 5, 6. It extracts the 6. That's simple. I would kind of encourage you to do some examples on it and just explore different possibilities and transpose it. Like this, we call it transpose, right? So we convert it into vertical format or vice versa. So I encourage you to do some examples on it and explore it so you can fully understand it. And again, I would like to emphasize it more that it is vital for matrix calculations. See you in next part. Hello again. We're back with vectors, and I would like to give you a practical example here. So let me clear the screen. As you remember, we had a vector, which is the speed of the car, the first car, not the speed, like the data for the first car. So it was 2, 5, 6, and 8. Okay, this was some information about it. And the b equals to 3, 1, 5, 9. All right, so I just made two vectors with the same length. And someone might ask you how faster the car A is in comparison to car B. So what you can do, you can come here and say, okay, the 5, this one, the second part was the speed. Okay, it was associated with the speed. And so what I can do is to extract the speed of car A and then divide it by the speed of car B, and then I have the result. So the way I do it, as we'll learn, we put A 2 divided by B 2. If I do that, you see that the speed of car A is going to be 5 times bigger than the speed of car B. This was a really simple example to instill the idea. Another important thing that I would like to tell you is the workspace. So far we've used it as recording some data here, but I would like to tell you that there are occasions where you just type a vector and you might say, oh my god, I did the third column, I did it wrong, and you did a lot of calculations afterward, and you didn't realize that this number was wrong at the beginning. So what you can do, instead of just retyping everything, what you can do is come here and double click on it, so it will open as a spreadsheet like document, so sort of like Excel, and then you will realize that the second item here is 5. This is the same vector, by the way. It's A, and this is the same vector. It has 4 elements in it. So if I double click on this one, you will notice that I can change it to, let's say, 8. Okay, and hit enter. Then close it. And then I realized that, oh my god, I did the same mistake for B2. So I come here in B and just type 7. All right, I change it. Hit enter and close it. Now if I do the last calculation again, you see that the result is different. So if I say, let's do it this way. Now I'm going to bring out the A. You will realize that the A now is 8. The second item is 8 because we change it. And how about B? The same thing. It's now 7. So the result will be different also. This is a very handy way that if you ever realize that you did a mistake and you want to calculate again or just revise your calculations, this is a very convenient way to do it. Hello everyone, welcome back to MATLAB programming course. In this part, we're going to learn how to do algebraic equations with vectors. So let's get started. Let me define vector 1, 1, 2, 3, 4, and 5. And vector b equals to be 5, 6, 7, 8, 2, yeah. And then c equals to 0, 9, 6, 2, and 4. Something like that, random. Okay, so I created 3 vectors which has the same length. Now I can do this. I can do a plus b, okay, because they have the same length. What MATLAB does is just add element by element. 1 plus 5 equals 6, 2 plus 6 equals 8, 3 plus 7 equals 10, 4, 8, 12, and 5 to 7. So it can add these 2 vectors together. It also can subtract them. It's like that. And also we can subtract b minus a. Okay, so this is going to change the sign, and we can do A plus C. Totally fine. And we also can A plus B plus C. So MATLAB has no problem with these because it can calculate these operations as long as they have the same length. Now let's try multiply. A multiply C. And you will notice that MATLAB gave me an error because the dimension doesn't just match up. And we will explain this stuff in matrix section, but just wanted to give you a short introduction about the vector dimensions, because you might think that you need to do multiplication with vectors as well. So let me clear up the screen. We are able to do multiplication of one element to a vector. So if I do A, which is like that, and I need to, let's say, make every element 8 times bigger. So what I do is 8 multiply A. If I do that, you see that now the results are different. We can choose a negative number, -2 multiplied by A, or let's go B. If I do that, it just multiplies -2 to each element of B, and B is like that. So -2 multiplied by B is going to create -2 times of each element here. Hello everyone, welcome back. In this part, I'm going to start a new part in vector calculation, and it is multiplication, a different sort of multiplication in vectors. Well, there are two types of multiplication in vector and matrices. One is called dot product, and the other one is a cross product. Okay, so we're gonna start with these two first. Let me write down the A again and B, and here I do have two vectors which has the same length. This is important, the same length. Okay, now I wanted to calculate their product, and by product we realize that if I do A, B, it just gives me an error because we cannot multiply two vectors with the same dimension. The way that we can do to kind of find their product, which going to be this one multiplied by this plus this item multiplied by this and continue like that, is a function called dot. There's actually a function dot, and it will ask us to pass two values. So one is going to be vector A and the other B. So what it does, it just calculates vector A and vector B together and sum their calculation to see what's the result. When I do that, it gives me one single number. Always keep in mind that the result of dot product is going to be one single number. I can get the same result this way. So if I say A multiply B transpose, okay, AB transpose. So if I hit enter, it's going to give me the same result. But how does it calculate it? So if I say A, which is this, then B transpose this. Now if we just multiply these together, we get the same result. A multiply B transpose. It will give us the same result as a dot A and B. And it is really important. Okay, so let me clear the screen. Now I'm going to explain about the cross product. And as you know, cross and dot product, which is also known as a scalar product, are fundamental calculations and operations in engineering. And no matter what your field of engineering is, you will need this in your projects, homeworks, or research. Okay, so now we're going to talk about the cross product. Cross product and dot products are very important and crucial calculations in engineering field, and no matter what your major is, you will need them at some point in your homework, in your projects, in your research, and the concept is also important. Here we're not dealing with the mathematics, but I'm going to show you how to use MATLAB to just ease your way and get the result faster. So I'm going to create a vector called A, 1, 2, 3, and B equals 5, 6, and 7. Okay, and what it does, oh, I forgot the sign again. Okay, what it does is that the first item represents the X, the second item represents the Y, and the third item represents the Z. And now what we can do is to type cross, and it will just give us a hint, A, and the second item is B. So what we're gonna do is multiply the cross product, use the cross product to do the A vector and B vector. And if I do that, you will see that a new vector is going to be created. So if I say, name it C equals the cross product of this, now a new vector is created. And what is the cross product? It is like when you have an A vector and B vector, the C one is going to be created in such a way that's perpendicular to both of these. And if you just test that by yourself, you will notice that the result is correct. So this one is important when it comes to finding a vector which is perpendicular to both. There are a lot of applications for this. One of the most famous one is in a probability and estimation theory, where you want to find the vectors which are perpendicular to another vectors to reduce the estimation error, to minimize it as a mean estimation error. Please create some examples for yourself and just try to familiarize yourself with the concepts, with the engineering, with the mathematics behind it, so you feel comfortable when it comes to using them in real programs. Hello and welcome back to next session of the MATLAB programming. In this part, we're going to explore some new functions on vectors, which are really important, especially when used in programming and analyzing data. So let me try out with defining a new vector, 1, 2, 3, 5, 7. Okay, this is my new A. The first item that I wanted to talk about is finding the length of a vector. Okay, there are occasions where you had a large array of vectors and you need to know how many data points are in there. So maybe you want to take the average, maybe you want to just know the number of the data points, or those data represent some specific meaning for you. For any reason, you need to know how many elements are in there. There is actually a function called length. So if I type length and A, because A is my vector, it will give me the number as 5. So there are 5 elements in it. And if I define a bigger one, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and just random numbers. Okay, so I created a big vector, and later I will show you how to do it much faster and in a better way. But for now, we just stick to our conventional methods. So I found a vector that has a lot of values, and it's not intuitive and easy for me to just go and 1, 2, 3, and how many elements are in there. The way that I can do is to use length. Length function is going to go and count it for me and bring it the result. So if I do that, the result is going to turn out to be 17, which is very easily calculated. You can also do some other stuff with the length. For example, I can do length of A divided by length of B. Okay? I can easily do that, and it will give me the result. It might be meaningless at the moment, but there are engineering elements or engineering applications where these are really important. And I will give you one in a moment. Okay, so let me clear up the screen. There might be occasions where you're interested to find the sum of the elements inside a vector. For example, I do have A here. I want to know what's the summation. The way that I can do is to use function sum. I write sum and then open parentheses and type my vector name. When I do that, MATLAB is going to go and add all these elements together and return the results. which is very easy. For example, imagine the B. Let me bring the B. It's gonna be a much easier one. Okay, so imagine the B is going to represent the grades of students in a class. You know, it's a terrible class. It has 1, 2, 3, 4 B, and you know, it's just a very, very lazy class. And the teachers just need to know what's the average of the class, okay? The way that we can do is to sum all the values, which is going to be, so the sum turned out to be 134, and then length of B, which turned out to be 17. Then we can find sum of B divided by length of B. All right, so if I do that, it turned out to be 7.8 as the average of the class. And we can do a better way to find to use the mean function, mean of B, which does the same thing for us. It just goes and find the average of that vector, which represents some sort of data. The other important functions that we need is the mean and max. If you ever wanted to find the minimum value of a vector, you can do it by typing mean. Okay, so the mean value of A is going to go search the vector A and find all the elements and then bring the minimum one, which is 1. The same one with B. If I do that, it will bring the minimum one as well. And you're able to do some sort of calculations with it as well. How about the max? So the max of A is going to be 7. The max of B is going to be 45. And if this area of data, the B1, if it was representing the temperature, for example, in a refinery or something, and then you're asked to write a program for this refinery to watch the temperature, and if the temperature goes beyond, let's say, 12, then it alarms you, okay? So goes above 9. So even 12 is not allowed. So above 9, it should alarm you. What you can do is to find the maximum value of this vector and watch that value, write a condition for that we later explain, and tell MATLAB that if this value ever goes above 9, just do these stuff, okay? So this is gonna be some of the functions that they can use, a very simple one. And don't worry, we're going to learn the conditional programming as well, and I will explain all the sort of stuff to you, so at the end you're fully able to write a functional program. Hello and welcome back to MATLAB programming. In this part, I'm going to show you how you can easily create a vector and also extract some part of a vector. All right. One thing that I would like to explain here is that, as you remember, I can say A equals 1, 2, 3, 4, 5, 6, 7, 8. Okay. I can define A like that. But also, I want to tell you that you can create A like this. So you start 1 colon 8, okay? 1 colon 8, and look what happens. If I do that, you see that the same result is created, and A is also a vector as well. So the first one we created like that, and the result was this. The second one is also another way to create a vector very fast. So if you decided to create a vector, but you didn't want to just type it like that, you can use the colon. But remember that this colon represents that the first item is 1, the last item is 8, and it increments with 1 item. So 1 plus 1, 2, then again 1 added to 2 becomes 3, 1 added to 3 becomes 4. So as you see, the difference between these are all equal, and it is equal to 1. So this is the way you want to do it. But how about if you want to create a vector which jumps 2 steps ahead, not 1 step? So I can do that by b equals 1 colon 2 colon 8. Now I will tell MATLAB that start from 1, go to 8, but not 1 by 1, just jump 2 a step. And if I do that, you see that after 1, 2 is going to add it to it, becomes 3. 3 added to 2, 5. 5 added to 2 is going to be 7. So this is another way to create a vector with some specific elements. What is frequently used in MATLAB programming is that when they wanted to define time, they say that, okay, let's just start from 0, colon, and go very small part ahead, 0.1, and then colon, let's say 5. And if you hit enter, you see that a lot of columns are created. So if I type t here, you will notice that it's lengthy, and now let's find what's the length actually. Therefore, we come here and type length t, and if you hit enter, there are 51 elements inside the t vector. So these are the new ways that we can define a vector. So you will see them a lot in different programming contexts. So let me clear up the screen. We already learned that if we have a vector like A, and if you're interested in the third element, we can do it by A3. So it brings out the third element for us, or let's do with B. Let's say fourth element. It's going to bring out the 4 part in vector A. But what is interesting to know is that you can extract not a number, but also a portion of the vector. So if I type A equals, now if you tell me I want to extract starting from the second element up to the 5th element, so I can do 2 by 5. All right, 2 colon 5. What it does, it goes and extracts only that portion of vector. I can similarly do 2 to 4. Okay, so it goes and starts from A, 2, 3, 4. It brings out the 3 elements. CLC. Okay. Another important thing that I would like to inform you about is another function called linspace. Okay, so linspace comes from linear space, and if you type it, let me bring it here if I can. I can't. Okay, so do it this way. Should be able to bring it more help on it. Okay, here we go. All right, so if you type linspace, it will bring the function, and there are 2 ways that we can do it, like linspace A and B and linspace A, B, and N. So one item has 3 arguments, the other one has 2 arguments. So what it does, linspace, as you come here, linspace A and B generates a row vector that has 100 points linearly spaced between and including A and B. Okay, so if I come here, let me take it there. Okay, so if I say linspace 1 and 10, what it does, it creates 100 points which are spaced exactly equally between starting and including 1 up to 10 and including 10. So if I do that, it just creates 100 items for me, which is linearly spaced. Another one is linspace starting from 1, ending from 10, and like 5. Okay, what does this item, which has 3 parameters, do? This function starts from 1 up to 10 and creates 5 items which are equally spaced from 1 up to 10. So if I do that, you will see that the first one is 1, then 3.2, 5, and 5.5. So 1, 2, 3, 4, and 5. There are 5 items here which are linearly spaced. These are also new ways to define vectors in MATLAB. The last thing that I would like to emphasize in this video is that when you extract a part or create a new vector, you're fully able to do some calculations on it, do multiplication, division, or some mean and average thing on it. For example, if I say mean of n's, which is the last result, it's going to give us very easily about it, or length of n's, and the result is, oh sorry, the length of, so let me put this one into a new variable called c, and now I can find the length of c, which is going to be 5. So there are a lot of calculations that you can start working with and practice on it until you're fully confident with MATLAB calculations. I hope that so far you've made a great progress in MATLAB programming and you're enjoying the class. Thank you very much and see you in next video. Hello everyone, welcome to MATLAB programming course. In this part, I'm going to show you how we can create bigger vectors from existing vectors. So for example, you have some sort of existing vectors or existing data from one sample and the other one also. You want to join them together. How are we going to do that? Let me define two new vectors, 1, 2, 3, 6, 9, 10, and 6 again. Okay, this is going to be A, and the B is going to be 3, 6 minus 1, 8, 2, 8, 2, 7, 1. Okay, so we created two different vectors which are not the same length as well. And then I define vector 1 equals. So I would say A, and I want to extract from the third element up to fifth element. So let's go 3 to 5th, third to the 5th. Okay, if I do that, vector 1 is created. How about vector 2? Vector 2 is going to be equal to B, but starting from 2 up to 7. Okay, so I created a new vector, which is extracted a part of the vector B as this one. So you know that vector 1 and vector 2 are created. They're part of other vectors. There's some sort of new data, and we're going to combine them together into a new vector. The way that you're going to do that is to call vector 3. So vector 3 is created. Now I put vector 1, comma, vector 2. If I do that, look what happens. MATLAB creates a new vector which is bigger, and it consists of vector 1. So vector 1 is 3, 6, 9, 3, 6, 9. Up to here is vector 1, and then 2 to 7, which is going to be 6, negative 1 here. 6, negative 1, 8, 2, 8, 2, and it's going to combine it here. We also can get the same result, but transpose it to create a vector which is vertical. This method is used in MATLAB programming frequently, and you will see a lot of programs like this. Now we can also add to this one with the fourth vector. So let's call vector 4 equals, starting from, let's go with linspace. Linspace from 1 to, let's go 9, and how many? Let's go with 5. All right, so I created a new vector, which is vector 4, which has 1, 2, 3, 4, 5 elements linearly spaced. Now I want to combine it to the vector I already had. So I go vector 3 equals vector 1, vector 2, and now vector 4. Okay, If I do that and then transpose it, you will see that I added a new vector here. How about the sum of vector 3? Pretty easy. Max of vector 3. Minimum. I just try to review some parts with it together like that. Okay, so it's really easy that you can work with different vectors and combine them to see how they're created. Hello and welcome back to MATLAB programming course. In this part, I'm going to show you how we can do a new sort of vector multiplication, which is really important in programming, and you will find a lot of occasions where none of those types that we already learned, the cross product and the dot product, are going to be useful for us. But this type of multiplication, which is not a formal type but a common one, would be our solution. So let me define two vectors here. Vector A is going to be 1, 0. To show you this example in a better way, I just want to use 0 and 1, like bits and bytes of a computer. Okay, so I create some vectors here. Okay, and the B is going to be equal to 1, 1, 0, 1, 0, 1, 0, 0, 1, 0. Right there. Okay, so I created two vectors. They can be different numbers. They might not be 1, 0 only. You can use whatever number you want to use, but I want just to show you how we can use this stuff here. Okay, so as we learned, we're able to do dot product of A and B, which is a number, and also cross product of A and B. Oh, sorry, we cannot use cross product. I did a mistake here, because cross only is defined for vectors at most 3 items. I just did a mistake here, my bad. Okay, so now sometimes you need to do multiplication of two vectors that are 1 by 1. For example, you want to multiply the first element in vector A to the first element to vector B, and the second element in vector B to the second element in vector A, and do it continuously. Okay, for example, you had two vectors with thousands of length each one, and you want to multiply them together to see what's going to be the result. The shoot here is that these two vectors should be the same length. Okay, without it, you cannot do that. The way that you are able to do some sort of calculation is this one, and please pay close attention to what I'm going to do. So I type A, then I type dot, A dot, and then multiplication sign B. Okay, it is something new. So before I do that, let me eliminate the that dot here, and I'm going to hit enter. You'll see that we cannot do that because these vectors are actually matrices. They're not vectors, they're matrices, and matrix multiplication has its own rules and regulations that we're going to observe in matrix section. But for now, let's try it. Let's try to write it this way. So I type A dot star B. Okay, so I calculate this one. Now look what happens. If I hit enter, a new vector is created, and it's lengthy. Let me bring it here. Okay, so the first element is 1, 0, 1, 0, 1, 0, stuff like that. And if you come here, you will notice that the first element of A and B, if you multiply, is going to be 1 here. The second element, because one of them is 0, the result is going to be 0. The third one, the same. If you follow the pattern, you will notice that we did it. We could divide, we could multiply each element by its corresponding element in another vector. The same way we can do this by division. So now you're able to do the division, and you see that there's NA non-applicable because it's going to go infinity. All right. The point here was that you are able to do the multiplication element by element in a list when you use the dot before the operation. So this is kind of important. We need to use the dot sign before the operation. Either it's division or it's a multiplication. We're going to use that before. So A dot division by B, and you will see that the result is going to be created. Hello everyone, welcome back to MATLAB programming course. In this part, I'm going to teach you how you can use mathematical operations on the extracted and generated vectors that we had. For example, if I define a new vector like 1, 2, 4, 6, 2.2, minus 9, and the b equals 2, 1, 4, 5, 6, and now what I'm going to do is to try some of the functions that we learned before. For example, if I say abs of a, absolute value of a, and you will notice that the last one, the negative 9, now turns out to 9, which is the absolute value, and there is no negative number between, so it just turned out that all values are now positive. The next one, sine of b. Similarly, I can do, let me clear this thing, and let me define a smaller one for a, 1, 2, 6, negative 3. It's better to just work with the smaller. And the b also is like that. Very great. Okay. Now I'm gonna find the log of a, and you see that some values are like complex numbers, but it calculated that, and sqrt of b. So if I do that, you see that now all the values in b are the sqrt, or the second root of these values, are now created here. How about tangent? Tangent of a. So we do have it here, or sine hyperbolic of b, the same thing, or a cosine of b, which is calculated. So you see that when you do have a sort of data, you can easily calculate different mathematical functions on its element and get new data as well. How about raising to a certain power? So let me clear that. And I wanted to raise a to power 2. Okay, so let me write a here again, and a to power 2. And you see that there is an error because we do have a vector and we cannot treat it the same way as we did with the sine, with the cosine, logarithmic function and stuff like that. But what we did in multiplication applies here as well. So if I say a dot raise to power 2, dot raise to power 2, it means that the power sign, the power function on each element of vector a. If I do that, you see that it's now calculated easily. A to power b. We cannot do that. How about a dot to power b? You see that it's now easily created. So these are the important functions and operations that I wanted to point it out, and there are a lot of occasions that we need to use these forms of multiplication or mathematical usage in our engineering endeavors. With that said, I will see you in next video. Hello everyone, welcome back to MATLAB programming course. In this part, I'm going to show you one of the most important subjects in our course, and it is creating vectors with random numbers. All right, first, before we get into vectors, it's better that we ease our way into random numbers and random functions through scalar cases. So if you want to calculate a function which has random elements in it, the way to create one is through using rand function. Okay, so if I type rand and hit enter, it will create a number for me. How about if I do it again? You will see that the result is different. Each time that you typed rand and do it again, you will get a new result, and that's the way it's designed. We're telling it to give us random numbers. Let me clear the screen. We're going to extend the same thing into vector concepts. If we need a vector with random functions, we can open parentheses, and MATLAB gives us some examples how we can do it. Rand n and rand mn, and if you type help, it will give you how we can do it. So rand of n returns an n by n matrix containing something that we're gonna cover later, but the rand m and n is something that we're interested at the moment. So what it does, I encourage you to read it thoroughly so you can get the most out of it. But for now, the rand, it accepts two parameters. The first one, I type 1, and the second one, let's go with 8. Or no, not 8, 4. Let's just start with something small. Rand 1 and 4. Let's see what happened. If I type it, it creates a vector with 1 row and 4 columns or elements. 1 row, 4 columns. 1, 2, 3, 4. Okay. So if I do the same thing again, you will see that now the numbers are different. How about now? Different, different, and different. So the same way that the rand function created scalars which are different, the rand, when defined for vectors, is also going to create new and unrepeated values and vectors. So let me clear up the screen. I can also do 2 multiplied by rand of 1 to 5. So if I do that, and before, let me do rand of 5 so you can see what's the result. And then if I make 2 times of that, it's going to create it seamlessly for me. The sine of rand of 1 and 3, 1 and 4 is going to be created as well. Okay, so any functions that we learned so far is going to be applicable here too. Now you might have guessed that what happens if I go with this one and change this one to 2? Well, you can have a sneak peek of that and you will see that it's going to create a matrix, and we're going to work with that in coming sessions. But you have guessed that rand is actually a fast way to create a matrix. Let me clear the screen. Occasionally, you might be asked to create some vectors with unrepeated numbers, okay? So if you want to create something which you're sure there is no repeated items in that, for example, you want to draw a wiener, okay, out of that box or out of that number, and you want to just have only one wiener. And someone comes to you and say, hey, could you write me a program that can generate, for example, 2 million numbers for me, and these 2 million numbers should not be repeated. And the way that you're gonna do that is through a function called rand perm. Rand perm. What rand perm is, if you remember in probability, there's a permutation and combination. So the permutation is where when you have different options which cannot be repeated. So each one of these options should be unique. But in combination, you're fully able to do that. You can have repeated items. here I type a number like 5, and if I hit enter, you will see that 5 numbers are created, which no one is the same. If I do that, not the same, not the same, and not the same. Another part that we might need to work with is when you need a vector which has all ones or zeros. Okay, occasionally you might need only a vector which has ones. All right, so ones, if I do that, it asks me how many you need, and I will say 7. If I do that, it just creates, this is for matrices, my bad, ones. So if I go with that, I should select 1 and 3. If I do that, you see that the results are created. The ones that we had here also used in matrices a lot, and we will cover all this stuff later. But for now, just remember that if you wanted to create a vector, because this chapter is dedicated to vectors, I want to give you examples that are only for vectors. But you can just extend that to anything, just explore everything you see here. My advice to you is that just explore everything that you learn here and try to make things different for yourself. Explore that what happens if I do this parameter, I change it like that. Okay, and we do also have zeros of 1 and 5, for example, and it will create for me, or zeros of 1 and 3, and I do that. It might be hard for me to explain where do you need this stuff, but my point here is to show you how you can generate and automate your work rather than sitting down and create like rows with 100 items. And when we get into programming section, I will show you a lot of examples that you can that these functions come handy, and you can explore them by yourself. One more function which is handy sometimes, and you might have used it in Excel, is the sort function. So let me clear the screen. Rand perm. I'm just going to create a random permutation of, let's say, 5. Okay, I created that. Now I want to sort it in a way that it's in ascending order. So if I say A equals sort of, before doing that, let me do it professionally. I create a function called, a variable called A, and then I create a new one called B equals to sort of A. Okay, and if I do that, you'll notice that now it's created 1, 2, 3, 4, and 5, which is in ascending order. Hope you used the functions along with me and learn how to combine them as well. See you in next video. Hello and welcome back to MATLAB programming course. Today I'm going to teach you how to do basic statistical analysis on your data in MATLAB, and I wanted to tell you that MATLAB has a very powerful statistical toolbox installed, and you can read the help manual and just use the statistical analysis if the statistics, economics, and stuff like that is your major. But even if you're an engineering student, you occasionally need to, not occasionally, actually frequently, you need to work with the statistical results of the data that you derived, and you need to know the relationship in your set of data, both as data validation and also finding the accuracy of your data. So today we're going to cover some basic statistical analysis here. So let me clear this thing, and let me define a new variable called, let me call it data, equals 10, 23, 89, 43, 387, 64, 12, and 49. Okay, so I created a set of data. Now I want to find the mean. So as we know, the mean of data can be calculated as using the mean function easily. How about the median? So the median can be found with the median function, like that, very easily. One of the other important functions in a statistical analysis is the standard deviation. So STD is a function that we use to calculate the standard deviation. So standard deviation of data will be calculated with STD. Another one is variance. The variance of data equals 977.55, and as you know that the square root of variance, so SQRT of variance of data is going to be exactly like the standard deviation. So if you calculate the variance and take a square root of that, it's going to be standard deviation. Here I'm not going to go after mathematics behind the statistical analysis and all these values, what are the mean, what are the variance, but I'm going to show you how you can find these parameters if they're important in your engineering project or homework. Again, I would like to emphasize that please don't forget to use the help of the MATLAB. It is one of the most amazing sources of learning MATLAB, especially when you can copy paste examples there and just verify your theories this way.